notation. This is section 2.6. Function notation and linear functions. Okay, so just as a reminder, what a function means. Function just means a relation where 1x goes to 1y. That's what we talked about. If you have a problem where it's written y is equal to x plus 1, when x is 2, y is 3. When x is 3, y is 4. When x is 4, y is 5. Every time we plug in one x value, we get one y value. So this is a function. Plus it's a function, we could write it f parentheses x equals x plus 1. These are the same thing. But this bottom one just tells you that it's a function. F of x is the same thing as y. It's just one extra piece of information that says it's already a function. You don't have to figure it out. I'm telling you it's a function. Does that make sense? We read this f of x, or f is a function of x. We don't say x times x, we don't say x parentheses x. That's not how you read it. F of x or f is a function. F parentheses 1 means evaluate f of x when x equals 1. Let's actually do that. So if I asked you to find f of 1, what this means is we just plug in 1 for the x. This just means 1 plus 1, which is 2. That would be the answer. Another way to think about this is what is y for f of x when x equals 1. There's just a couple ways to think about this. We'll do some examples, and I'm sure you'll get the hang of it. I have 4 examples here. Let's say given f of x is equal to 6x minus 2. Evaluate 2 things. Let's evaluate f of negative 3 and f of 0. All right, so f of negative 3 just means we put negative 3 in for the x's. Six times negative 3 is just negative 18. Negative 18 minus 2 is negative 20. That would be what the final answer is. F of 0 just means we put 0 in for the x. 6 times 0 is 0. Minus the 2 is negative 2. You guys think you can handle that stuff? So let's make them a little bit more challenging. What if I said given g of x is equal to negative x squared minus 3x plus 3, evaluate of negative 3 and f of a. And in math, we just have rules. You follow the rules all the time. So, oh, I said f, I'm sorry. My mistake. I meant to put g. We're plugging them into the function g of x. So let's follow order of operations. Negative x, which was negative 3 squared, minus 3 times negative 3 plus 3. You have a calculator, you could just type it in. For this particular problem, we want to make sure we follow order of operations. Negative 3 squared is 9. We did exponents first. Negative 3 times negative 3 is positive 9. And negative 9 plus 9 is 0, plus 3 is just 3. The rules don't change if we plug in variables. Just because I asked you to plug in a doesn't make anything any different. We just plug in a for all the x's. We get negative a squared minus 3 times a plus 3, which is just negative a squared minus 3a plus 3. There's nothing else to really do there. On your exam 1, it'll have numbers. So it'll say g of 2 or something like that, and then you just plug that in for a. More examples, just giving you a little bit of a different angle on this. If I said given h of x is equal to 5x minus 1, evaluate h of x plus 2. The rules are that we just plug this in for all the x. So according to this, instead of x, we're going to replace it with x plus 2. We distribute the 5. 5x plus 10 minus 1. 5x plus 9. something like this. I said, find f of 2 for the following. What if I told you function f of x, or just f, is equal to 2 comma 6 and 4 comma 2? This is a little bit of a different way to look at these problems. This is asking you, what is y when x is 2? What is y when x is 2? Okay. There's a different way to look at it than the other one. What about if I said f of x is equal to negative x squared? I'm asking you to find f of 2. What this means is we just put 2 in for the x's like we did before. We get negative 4. As a reminder, negative 2 squared is different than negative 2 squared. Just as a little reminder, this is a totally separate problem. For the problem on the right, this just means we do negative 2 times negative 2, which is 4. For the problem on the left, that means we do the opposite of 2 times 2. Just so you know, those are different problems. Parentheses are important. Whenever you plug in a number, you want to make sure you use parentheses. I'm just going to say use parentheses whenever you plug in numbers. Do one more of these. What about if I told you that f of x is equal to 1, 2, 3, 4, 5 in each direction? Is I want to put a point right here at 3, 0. Point right here at 0, 1. I want to connect those dots. I get a graph that looks like this. I want to try to figure out what f of 3 is, what f of 0 is, and then what f of negative 2 is. Remember what this is asking you. What is y when x is 3? What is y when x is 0? What is y when x is negative 2? So as long as we understand what that means, it's great. Second half of this section shouldn't be a big deal here. I wanted to go through an example where we write equation using function notation then evaluate f of 1. The equation is x squared minus 4y is equal to 3. So this whole thing about getting it in function notation, this just means we want to have it y equals a number. So we want to try to solve for y. So if we want to try to get y by itself, what we could do first is start from the outside and work our way in. So first thing we could do is subtract x squared on both sides. And then divide by 4, or negative 4. This will just turn into y is equal to 1/4 x squared minus 3/4. We could just write f of x instead of y. And that takes care of the first part. The second part is we just have to evaluate f of 1. So if we're trying to figure out what f of 1 is, one squared is just 1. 1/4 minus 3/4 is negative 2/4, or just negative 1/2. Wanted to finish class up with just some graphing problems. So what if I asked you to graph each function and then give the domain and range? Let's start with a problem like this. It says f of x equal to negative 1/2 x plus 3. Remember, f of x is the same thing as y. This is just y is equal to negative 1/2 x plus 3, where 3 is the y-intercept, and negative 1/2 is your slope. When we talked about slope, we said the top number tells us to go up or down. The bottom number tells us whether to go right or left. So if the y-intercept is 3, and the slope is negative 1/2, that means we're going to go down 1 and to the right 2. Be the domain for this problem. All real numbers. The way that we write that is on the left side, we say how far left it goes, and then comma how far right it goes. For this problem, it's going to be negative infinity to positive infinity. When we're talking about the range tells you how far down you go, and how far up you go. It looks like it goes down for forever, and then up for forever. Typically where the infinity is. If we had a problem like this, f of x negative 1.5. Remember, f of x is the same thing as y. Y equals negative 1.5. Is that a horizontal line or is that a vertical line? Anytime you have y equals, it's a horizontal line. The negative 1.5 would be right here. Y equals negative 1.5. That's what it looks like. Remember, anytime you have y equals, we say that the slope is 0. For this problem, when we go to say the domain, this graph goes all the way to the left and all the way to the right. So we would say from negative infinity to positive infinity. What about the range? Range isn't undefined. Range is just possible y values, right? So what's the only possible y value? 1.5. We can try it like this. What if we had a problem where it's x is equal to 2? That's a vertical line. The slope here would be undefined. anytime you have a vertical line, it's x equals, and the slope is undefined, we would say that the domain would just be 2. The range would be all real numbers, which we write negative infinity to positive infinity. And one more example for tonight. We are going to end a little early today, so if you guys have any questions from the test, I'll stick around until 6:15 if you'd like. You could ask me questions. We can go over whatever. But after this problem, you're free to go home if you'd like. What if we had f of x is equal to x? Remember, this is the same thing as just y is equal to x. It's almost written in slope-intercept form. If I put a 1 over 1 here, and then if I put plus 0, it's a lot easier to graph. We know that the y-intercept is 0, the number there. And this is the slope. Slope number was up or down. Bottom number tells you whether you go right or left. We're starting at 0, going up 1 over 1. The domain and the range for this problem would be all real numbers. And that's it.